In this video, we're going to be looking at discrete data, which is different than continuous data, and it means that the points are not connected. So notice on here that we don't have any lines connecting these points. Therefore, we call it discrete data. And I'm going to give you the domain and range, and I'm going to go ahead and tell you if it's a function or not, and show you how to fill out the table and the ordered pairs when you run into a problem like this. So let's go ahead and let's take a look at this first part. First, we want to go ahead and we want to give the location of our ordered pairs. So I'm going to go ahead and write my parentheses here for each one of these. And then we'll transfer them down to the bottom of the paper into the table. Now, when I'm looking at my x values, right, my x-axis goes left and right. The x value always goes first, and your y value is always going to go second. So I'm going to find my x value. So this one, I go over 1, 2. So this goes as far left as -2. So I'll put that for my x value. And my y value is how far I go up from origin. So I'm going to go up 1, 2, 3, 4. So that's going to be a +4. Now, I'm going to go ahead and find this next one. I notice that this one lines up with 1, 2, 3. Let's see, 1, 2, 3, 4. So I'm going to put a line right here that is +4 on the x-axis. So I'm going to put a 4. And I want you to notice in this case, we actually have a point, 2 different points on 4. So I'm going to put a 4 right here. And our y value for the one above, it's up at 1, 2, 3, 4, 5, 6, 7, 8. So if I go over here to the y-axis, this is located at 8 on your y-axis, and it's on 4 for the x-axis. Now this one at the bottom, while it does line up with 4 for the x value, it lines up with -1. So I'm going to put -1 for my y value. So in other words, it's down 1 from origin at -1. So I'm going to put -1. And then my x value of this last point, the one that's furthest to the right, is 1, 2, 3, 4, 5, 6, and 7. So I'll put a 7 there. So that's 7 for my x value. And for my y value, it's up 1, 2, 3, 4, 5. So it's +5. So if I go all the way over here to the y-axis, it's at +5. Now we labeled some points, right, on our axis, right, so we can look at those values and refer back to them. And we labeled all our ordered pairs. So let's go ahead and fill out our ordered pairs. The one that was furthest to the left, I had -2 and +4 for my y value. And for this one down here, we had +4 for the x value and -1 for the y value. And then for this one, we had +4 for the x value and +8 for the y value. And for this last one, we had +7 for the x value and +5 for the y value. Now I'm going to go ahead and fill in my table as well. Let me move this up just a little bit. And so my x values are going to be -2, 4, 4 again, and 7. And then my y values are going to be 4, -1, +8, and +5. Now we have the question here is this a function? Now first I'm gonna focus on the graph. I am gonna do a vertical line test, and remember the vertical line test is if I create a vertical line anywhere on this graph, right, anywhere, and if it crosses more than one point on the same x value, it's not a function. For instance, if I cross here, that's looking good, but when I cross here, notice it's going to contact 2 points at the same time. One up here at 8 and one down here at -1. Because of that, it is not a function. So I'm going to put right here, not a function, because x repeats. Now I am going to draw my vertical line just so I can show you what I mean by x repeats in case that wasn't clear what I did right there. So I'm going to do my vertical line test. And remember, we can do the vertical line test on any area of the graph. And on all areas that we test, it should always only contact an x value one time in order to be a function. But that's not the case. Notice this vertical line, when we drew it down, you can see it contacts it at 4, 8, and it contacts another point at 4, negative 1. So right here, this is my vertical line test. And my vertical line test proves that this is not a function because x repeats. Now, I feel like the easiest way to tell that it's not a function, or the easiest format, is in a table, right? Because in this table, we can see right here very clearly that we have a 4 and we have a 4 repeating. So I'm just going to write a note right here. I'm going to put x repeats. Not a function. On the other hand, over here, if we're looking at the ordered pairs, I feel like if you just look at the x values, you can see that we have this 4 and we had this 4. So once again, x repeats. So it's not a function. Now, of course, the vertical line test proved that it wasn't a function, but depending on your test or your assessment or your classwork, right, they may give you ordered pairs, they may give you a table, or they could give you a graph. But here you can clearly see that this is not a function. Now, just because it's not a function doesn't mean it doesn't have a domain and range. So we still have a domain and range for it, even though it's not a function. So let's go ahead and go over here and let's write the domain and range for this particular situation, this particular graph. Now, when it comes to discrete data, because remember, I'm going to go back to our first point, is that this was discrete data because the points are not connected. And when we write the domain and range for discrete data, we're simply going to do it with brackets. So I'm going to start off, I'm going to make these kind of weird looking brackets here. And we're going to write the points, the numbers, one at a time. And we start with the furthest left value, in other words, the smallest number. So we go to the furthest to the left for our domain. And the furthest this goes left is right here. It's going to connect it, is negative 2. So I'm going to go ahead and write negative 2 for my x value. Negative 2, comma. And then I'll go to the next. And I'm going to move over. And the next one, notice we have 2 points here, right? And they both lead to positive 4. So even though it has a 4 repeating, it has it twice, we don't have to write it twice. We just write it one time. So positive 4. And then the furthest point to the right is this one right here, which lines up with positive 7 on the x-axis. And so I'm going to put a 7. And then I'm going to close my bracket out because that is its domain. So its domain is the furthest it goes left is negative 2. And then the next is going to be 4. And then the greatest value that it goes to is 7. So it's in between these areas, right? And it's at specific defined points. Now, let's do the range. So what's the furthest it goes down? So the furthest it goes down, looking at it, is going to be right here at negative 1. That's my lowest point. So I'm going to start with that one. So I'll draw my brackets. Again, this is discrete data. So I'm going to put negative 1, comma. And if I move up from there, I can go up right here. Notice that this next point lines up with positive 4 on the y-axis. So positive 4. And if I move up a little further, we have this next point, and it lines up with positive 5 on the y-axis. So I'm going to put positive 5. And if I go up to the furthest one, the highest point, the greatest value of y, it lines up with positive 8 on the y-axis. And I'll put positive 8. Now, unlike the domain, when you're looking at the range, we actually have 4 values. And that's because there is a different value for each point. But with the domain, we did have a repeating x value, so we only had to write it once. That is my domain, and that is my range. And this is not a function because x repeats.